Hi guys, welcome to a Machine Learning Friday. I am changing the rhythm of my machine learning output just for this week because I want to show off a project I've been working on. So we have been hearing a lot in the news recently about how A&E waiting times are just out of control. And it's actually one of the NHS's strategic priorities for 2023-24 financial year to reduce waiting times in A&E. Their target is for every A&E in the country to see 76% or more of the patients within 4 hours of their arrival. Now, I wanted to do some analysis and some forecasting on how likely they are to meet this target as things currently stand. So I have built this week a data pipeline using Azure Data Factory and a small machine learning project using the Azure Machine Learning Software Development Kit. Gosh, that's a mouthful. So we're going to start by just examining both of those things before I delve into the visualization side of things in a future video. So here we are in my demo air recorder, and we're just going to quickly navigate to Azure Data Factory, where we're going to see my data pipeline. So here I have a quick pipeline that I built that looks up each record in a configuration file that I have, and that configuration file is actually a JSON file. And in that JSON file, I have the URL of each CSV, which basically points Data Factory to this website, the NHS statistics website, where I can download the CSV and bring it into a blob store. So inside this, for each, it loops through this list of CSVs and their URLs. Inside this loop is the copy activity. And I have actually parameterized this activity so that it points to each of these files, and it copies them using a different name for each of those files. So I've specified that in the JSON as well. Then we head over into the complete A&E pipeline. So in this one, we clear out the old merged files. We merge all of the files together into one giant CSV, and then a data flow happens. So a data flow is actually, it's really useful. It's used for transformation, for cleaning, for feature engineering. And here's what it looks like. Here's one I made earlier. So the data flow does things like filters out periods, columns. It filters for the big A&Es that we have in this data set. It selects the columns, and then it actually engineers some features. So the date column, there's a month and a year column. Unfortunately, I wasn't able to merge these into a date time column, but I was able to do that easily in the notebook. So I thought, let's take the easy win and do it there. Now we are going to navigate over to the notebook. So once all of that lovely data has been piped in to the blob store where I'm working, I can head over to the the Azure Machine Learning Studio, and I can start to build a machine learning script. So there are two ways you can run a machine learning experiment in Azure ML. There is the inline experiment and there is the script experiment. I'm going to show you both in this notebook. So here we have my notebook. I am creating my workspace. That is the central object in your machine learning workspace. So all of your useful bits and bobs like your compute are attached to this. I'm creating the data store and the data set from that blob store. I'm accessing it, and then I am going to start working on it. So here it is saved as a pandas data frame, pandas, of course, being the bread and butter of all data scientists and data analysts everywhere. And I'm just doing a little bit of data cleaning that I couldn't do in the pipe. And here we have some more data cleaning, and eventually we have our lovely clean data here. Now, an experiment is a run of a machine learning algorithm. In this case, we're using the Holt-Winters exponential smoothing forecast tool. So an experiment basically does a run of this, logs some metrics, and allows you to compare different iterations of models. So if you do some hyperparameter tuning or change anything else about your model, you can see whether it affects the overall performance. So this experiment creates lots of dictionaries. And the reason it creates lots of dictionaries is because I am generating an individual model and an individual forecast for every single hospital in this data set. I end up with about 200 machine learning models in this. And then we kind of, on a per model basis, forecast forward to see if that NHS trust is going to meet their targets. So here's our model dictionary. This generates a model for every single one of the keys, which is the hospital name. And then we do another model dictionary for the over 4 hours. So this one was for the number of people just going to A&E. This is the number of people who are going to be over 4 hours in their attendance. And then we predict into another dictionary. This is absolutely dictionaries everywhere. Finally, we are creating the mean absolute error and root mean squared error, which are both metrics for performance for these machine learning models. I am unfortunately unable to save each of them. You can see all of these have the name of a hospital and a value saved in this dictionary. Unfortunately, I'm not able to save this whole dictionary because it's too long. So what I'm doing is I'm aggregating them all together and making them into an average. So here's how I do that. I basically add all of them together, and then I divide them by the number of entries, and you get your mean average. That's how you run an experiment inline. Here we have the same script being run in an environment through a script. So we have to create an environment that contains all of the packages that we need so that that script can run in an environment where all of its dependencies can be accommodated. So I use all of these throughout this model. So they need to be there in the background for the model to pull upon, or the script to pull upon rather. We register the environment to my workspace, and then I can create this script run config object, which allows me to configure key things about the run and then submit the experiment. So what happens after I have submitted the experiment? Well, we can head over into the jobs section of Azure Machine Learning, and we can look at my A&E forecasts. So I ran these a bit earlier today. This was the inline experiment, my lemon engine. I love the names that it comes up with, and sweet table is my script experiment. So let's see what lemon engine logged. We can see that we have some metrics tabs over here. It's just loading at the moment. Here we go. So we've got our mean over 4 hours, mean absolute error, and our mean over 4 hours root mean squared error. And if we go back, and we have that for the mean attendance as well. And if we go back and look at the A&E forecast suite table, we can see that it has also logged some metrics. It has logged just 2 rather than the other one. And that's because I only did half the amount of experiments that I did in the first one. Up here, you can see the metrics in a different format, and we can also see any outputs or logs. So if I have any errors, I can see them here. And if you want to deploy a model, you can register it from here, and you can actually deploy it, which is great. I'm going to stop this recording now, but I am super excited to continue exploring the Azure Software Development Kit for machine learning. It's a really cool application that allows you to standardize the context in which you're running your experiment and track their performance over time. I can see a huge amount of value in it for iterative development of machine learning models for data science workloads. And it also has some fantastic integration with things like the Machine Learning Designer and automated machine learning, which are low or no code ways to do ML, meaning you don't have to have an encyclopedic knowledge of Python and pandas, which is fantastic. So I look forward to sharing that with you in a future Machine Learning Monday. But for now, have a wonderful weekend.